Hello, my name's Julian Edgar and I'm the author of the book Car Electrical and Electronic Systems. Now it's a book written for the modifier of cars, for the person who wants to work on their own cars. It's not written as a textbook for university or even a textbook for apprentices training how to be mechanics. It's for normal people who want to understand systems and be able to work on their own cars. Now, one of the things that I kept in mind when I was writing the book is that a lot of people seem to find car electrical and electronic systems incredibly complex. Even the electrical part of things, you can see that a lot of people don't have a clear idea of how the basic systems work. Now, if I were to give you a container, an empty container, and if I were to say to you, I want you to fill it up with 50 psi of fuel, you'd go, what? What do you mean? How many litres or how many gallons do you want? And you see the same sort of confusion occurring with electrical systems. People use the words volts and amps and ohms, and they don't really understand what they mean, and they don't really understand how they work together. So in chapter 1, Car Electrics, I cover those basic ideas. Now, they might be basic ideas, but they apply in any work that you're doing on the car electrical or electronic systems. From wiring programmable management to fixing your car headlights, these ideas apply. So, let's start off by talking about those ideas, and let's start off by talking just about a light bulb that's been wired into a circuit. Just a simple, straightforward light bulb, like this lovely antique light bulb that looks like it's from the 1950s or even 40s. When you connect that light bulb to a car battery, you will use two wires. One wire will come from the positive, it'll go to the light bulb. The other side of the filament of the light bulb will go to the battery negative. If they're all connected, if they're all continuous, then you have formed a circuit and that light bulb will glow. Now, any break in that circuit, because it will no longer be a circuit, think of it as a circle, any break in that circuit and the light bulb will switch off. Now that break might be that the filament has broken. The little bit of wire that glows white hot has broken, and so now there is a break in the circuit and so the bulb will be off. Or that break might be that you take one wire off one of the terminals of the battery. Or that break might be that you have put a switch in the circuit and that switch opens the contact. So the light will glow only if there is a complete circuit. Any breaks in that circuit and this light bulb will switch off. A short circuit is where the electricity can take a shortcut, not have to go through the light bulb, but can go directly from positive to negative. And as anyone who's done any work on a car ever will know, that would create a lot of electricity, a lot of heat would flow, it would be very, very dangerous. So all circuits that are effectively working in a car are complete circuits. Breaks in those circuits prevent it from working, whatever it might be a fan, not a light bulb. Break in the circuit prevents the load from actually operating, and a short circuit allows the electricity to bypass the load, and so again the load won't be operating and there might be a fire or other danger. Now that's straightforward, that's not hard to understand, so let's now put some terms together with what I've been describing. The battery that's been running our light bulb produces a voltage. When you think of voltage, think of it as the electrical pressure pushing the electricity around. It's an analogy. It's not really electrical pressure, but it makes it easy to think about it in that way. Think of the amount of electricity flowing through the circuit as the current, which we measure in amps. Now the amount of electricity flowing in the circuit is just like the amount of fuel that might be flowing in a fuel supply line. Then we'd measure it in litres per second or gallons per second. The amount of electricity that's flowing is measured in amps. Any obstruction that the electricity has to get through is called a resistance. The filament in the light bulb is posing a resistance to the flow of electricity. We measure resistance in something that's called ohms. So let's go back. Voltage, the pressure of the electricity if you like. Current, how much is flowing, measured in amps. Resistance, things that's trying to slow down that current flow, is measured in ohms, called, as I say, resistance. So voltage, current, resistance. They're the three things to always think about if you're dealing with any circuit at all. Any circuit in the car. Headlights, radio, electrical radiator fan, anything have got those three aspects to be involved with: voltage, current, resistance. Now, those three things are also in a relationship with one another, and here's where it gets really, really interesting. If you have 12 volts doing the pushing, if you have 3 ohms doing the resisting, then 12 divided by 3 gives you 4 amps. There's a mathematical relationship between them. If we know the resistance, let's say it's 3 ohms. If we know the current, let's say it's 4 amps. 3 times 4 is 12. We know there's 12 volts that must be doing the pushing. Now, it's called Ohm's law. You don't have to remember the mathematical relationship, but what you do need to remember is there is that connection between those three things. If we know any two of them, we can work out what the third one is. If we know voltage and current, we can work out what the resistance is. If we know voltage and resistance, we can work out what the current is. And that's extraordinarily useful. Yes, you can measure them with a multimeter, which I'll cover a bit later in another video, but the fact that there is a direct relationship between those three things is a really important thing to keep in your mind. So what have we talked about? We've talked about the circuit has to be complete for it to actually operate. We've talked about the fact that a short circuit is a bypass, a shortcut that goes around the load, and so the load won't actually be working. We've talked about the fact that the pressure pushing the electricity along is called a voltage. We've talked about the amount that flows is called a current, which is measured in amps. And we've talked about the resistance that's trying to stop that current flow is called resistance and is measured in ohms. And that final thing we covered, there is a direct mathematical relationship between those three things. Not one that you have to remember. You don't have to remember Ohm's law as such, but you've got to remember that those three variables, those three things are related, because that makes it so much easier to understand what's going on later when you're using a multimeter or when you're trying to work out why a circuit doesn't work. The book's called Car Electrical and Electronic Systems. This is some of the material that I cover in Chapter 1. I also talk about series circuits and parallel circuits. They're all really important ideas for you to have clear in your mind if you're going to understand how to work on these sorts of systems. Thank you.